Now we're going to try to familiarize ourselves with units by going ahead and deriving some units. So the first one, we're going to solve a lot of questions in this section, in this video. So let's look at force. Let's look at force. It usually helps to think of the formulas first. So we know from physics that F is equal to ma. M is mass. That's straightforward. But A is acceleration. What is acceleration? So this is going to be a tangent, okay? Acceleration is change in velocity over time. So the change in velocity over the period of time. All right. So to derive the units of force, we know that F is equal to ma. The unit of force is, the unit of mass is kilogram. And that's going to be multiplied by the unit of acceleration. Acceleration is the change in velocity over time. So the unit of a change in the parameter is the same as the unit of the parameter. The unit of a change in time is still seconds. The unit of time is still seconds. The unit of the distance in length is meters. The unit of a length in itself will also be meters. So let's look at that. The change in velocity as dv is going to be meters per second. And that's divided by time. So you're going to have seconds again as the denominator. So simplifying this, we now have that the unit of force is going to be kg meters per second squared. This is a kilogram. This is the unit for mass. This part deals with acceleration. You know that acceleration is velocity over time. So this meters per second is the unit for velocity. Remember, velocity is distance over time, displacement over time, distance over time. That's meters per second. And divided by time, all through, as 1 over s. So multiplying these through, this gives you m over s squared, which is the same thing as ms minus 2. That's how indices work, which is why you may see it sometimes as kg ms raised to power minus 2. All right, so we've done for force. Let's look at another units for work. Work done, remember I said look at the formula. Look at the formula first. The formula for work is going to be force times distance. Force times distance. Remember we just solved for the unit of force. That's kg meters per second squared. And the unit for distance is meters. So this is going to be pretty straightforward. The unit for work is going to be force kg meters per second squared. You can write it out either way, either making a whole fraction and taking s raised to power minus 2 down, or keeping it as kg ms raised to power minus 2. It still works. Times the unit for distance, that's m. Remember, we have m as the numerator here, and we're multiplying 2 by m, so we're going to end up with m squared. So the unit for work is going to be kg meters squared per second squared divided by second squared. We could also write this kg meters squared per second squared. This is symbolizing the fraction. So if you see it in either way, don't panic, don't get confused. All right, let's look at something else. The velocity of a gas particle. This is somewhat thermodynamics, but don't worry about it. The velocity of a particle v is the square root of gamma kb multiplied by t over the mass of the gas. So this is velocity. This is the temperature. This is the mass. Gamma is a constant, and Kb is the Boltzmann constant. So now we're asked to find, okay, that's number 1, number 2, number 3. We're solving number 3 now. We're asked to find the units of the Boltzmann constant, Kb. So the first thing to do is to make Kb the subject of the formula. So to do that, we have V here, and Kb is under the square root. So we're going to have to start by squaring both sides. The square of V is V squared. And the square of anything with a square root, the square root comes out, and you're just left with what's inside. So V squared is equal to gamma Kb times temperature all over mass. Now we're trying to make Kb the subject of formula, so you can cross multiply to get rid of the denominator. So you end up with mv squared is equal to gamma Kb times temperature. Divide both sides by gamma T to end up with Kb on one side of the formula. So you finally have Kb alone, and we know that we guess that Kb is equal to mv squared over gamma T. And the crucial thing to notice here is that numbers, simple plain constants like gamma, have no units of their own. Their unit is 1. Okay, so when you're solving for units, just take note of that. So now we can sub in for the units. For mass, we call mass is m, for velocity v, and the temperature T. So the unit of Kb is going to be, what's the unit for mass? Do be careful when solving questions like this, not to mistake m for mass as m for meters. This sim represents mass in the formula, and m, if we're dealing with distance, will represent, for example here in this question, m here represent meters as the distance. So do be careful. It's advised to go over your work to avoid mistakes like these. So the Boltzmann constant is m for mass, that's kilograms, times v squared. So what we're going to do is write the unit for velocity as meters per second, and then get it squared, divided by this. Remember I said the unit of gamma is going to be 1, and this is temperature, so it's going to be Kelvin. So dividing by Kelvin as times 1 over K. So evaluating this, we get kg times meter squared per second squared per Kelvin. So the unit of the Boltzmann constant is kg meter squared per second squared per Kelvin. Or you can also rewrite it this way: kilogram meter squared per second squared Kelvin. Do remember, or be careful to know that if you're writing your units with this slash to indicate division, anything below the slash should not have the negative sign. That will mean that you're dividing by 1 over something, and that will come up to the top, which would mess up your whole calculation. And the last question we have goes thus: a task was accomplished. Question 4. Within 3.2 times 10 to the power 6 of a year. Express the time taken in minutes and seconds. Time taken in minutes and seconds. So let's start with minutes, then we'll do it with seconds. A task was accomplished within 3.2 times 10 to the power 6 of a year. Express the time taken in minutes. Sounds complex. Sounds like a really big task. How do we go all the way from years to a minute? The gap is a lot. But you naturally you think of, okay, we got years, then we got months, then we got weeks. But you don't have to do that. If we know that there are 365 days in a year, then we can just go from year to days. I'll explain what I mean. And here you see why it's rather important to understand your units. So we're looking to convert 3.2 times 10 plus minus 6 over a to a time in minutes. So let's go. 3.2 times 10 raised to the power minus 6. Let's see if I can get more space here. Make this problem. So we're starting with 3.2 times 10 raised to the power minus 6 over a why r signifies here. So you ask yourself, we're looking to cancel out here. So how many days make up a year? So we'll multiply this by 365 days in a year. So if we were to convert 3.2 times 10 to the minus 6 years to days, we'll just simply multiply by 365. And we know this is going to be much easier because we can look at our units. Year is our numerator here. So if we're year, Y-E-A-R, is our numerator here for the first term. So cancelling this out, we know that this multiplication is going to give us this time in days. So this helps to foolproof and prevent against errors. But we're going down to minutes. We're going to need to more elaborate than that. So now we can think, how do I break down days all the ways to get into minutes? We can say, okay, how many hours make a day? Times 24 hours per day. So if you look at it this way, you've got year as a numerator, now as a denominator, day as a numerator, and now it's coming as a denominator. So we know that whatever we get here as multiple will cancel out year, and day, and leave us with hours only. But we've not been asked to solve for hours, we're asked to solve for minutes, and we'll go one more step. Times how many minutes make up an hour? 60 minutes per hour. So you can see if we cancel out all our fractions, year goes for year, day goes for day, and hour goes for hour. And this multiple is going to give us this time in minutes. So 3.2 times 10 to the negative 6 times 365 times 24 times 60. This time in minutes. That's going to give us 1.68 minutes. If we were to go to convert this to seconds, we can just carry this down. So 1.68 minutes times the number of seconds in a minute as 60 seconds per minute. Minute goes for minutes. And then we get 100 seconds. Approximately 100 seconds. So the understanding of units here really help us to prevent mistakes when solving, because you can see a question like this and be stuck, oh, do I divide by 365 or multiply by 365? Divide by 24, multiply by 24. But understanding the units helps to safeguard against these kind of errors.